I am sure you have seen these topics earlier, but it's good to start with them because something we would be talking about something called implicit function theorem, which is very important for economists, because we generally don't have explicit forms relating, let's say, economic variables. So we use very much implicit function theorem. We are interested in the direction of decrease, increase, and such things. This is one of the main tools which is used. And this is basically would be related to something invertibility. Okay, so if you listen to this part carefully, it will give you some ideas why we apply those kinds of methods that we see when in the case of differential calculus. I mean, we will follow with differential calculus. So what's the function? It's a mapping. Generally, it's called as a mapping. And we define the function here with f. Sorry. This is the function. F, and it's basically a rule. I mean, that's a kind of a, loosely speaking, we call it as a rule that assigns to each element of x in a set x. This is the, let me write it in this way, meaning that this x, basically small x, belongs to this curvy x, okay? And a function, this is important. If there is like a, let me call this x, and x1 is one element, x2 is another element, x3 is another element, and there is here another set, and that's what we call as y, and this y also has elements, y1, y2, y3, y4, let's say. If we define a function, we have to, or we talk about a rule that assigns each element of x into the elements in y. And when we don't have a function, let me show it to you. This might be boring, but still I want to remind it to you. If I define this in this way, is this a function? Can I claim that this is a function? You just write it in this way.
What about x3?
Exactly. This is the trouble. Each element of x must have a corresponding element in y. Okay? You can't just leave several elements of x being not assigned to elements of y. Then you can't have a function. So what about this one? Throw it again. Is this a function?
Yes, it is.
It is a function because there is no element of x which is not assigned into y, right? This is a function. This is a kind of a rule. But of course, this function will have some properties. Also, what we call here, we will look at in detail more of the things. And we call this as the domain, okay? And this set X, and this other set is called codomain, right? Set Y. One is domain, the other is codomain. So the set X is called the domain of the function f, and the set Y is called the codomain of function f. And when we define the function, we define it f mapping from the set X into set Y. Okay, so the function f maps the set X, this curvy set X into the curvy set Y. Or we can say that the function f maps the element of X, and then of course X belongs to this set X, into the element of Y, which belongs to this set Y. And f of X is called the image of X under the function f. Okay, so this is the f of X is basically the image, right? image of X depending on the rule which we defined with F. Now, we have some important points. Every element in the domain must be mapped into an element of the codomain. This is what we did here. Look here. Every element in X is assigned into another element in Y. There is no element which is left without assignment. This is what you should be careful. Some elements of the codomain may not be the images of any elements of the domain. Do we have such here? Do we have such here? This is the codomain, okay? For example, Y2, Y3 here, maybe I should write it as Y4 because it follows some kind of numbering. Can we say that some elements of the codomain are not images of X's?
Yes.
Which elements they are in the codomain?
I2, yeah, I3 and I4.
Yes, it's Y2, Y3, and Y4, they are not. But this doesn't make any kind of a, this doesn't make any trouble with something being a function. And this is what we indicate that no element of the domain is mapped to more than one element of the codomain. This is also important. I can't just take, for example, this X3 and map it to Y3. This is no as well. Okay, so this doesn't become a function then, because here X3 has an image as Y1 and also has an image as Y3, and this is not acceptable. Either it will be assigned to Y1 or Y3. If this doesn't happen, if there is such a thing as here, we say that this is not a function. So this is also something which we take care. And an element of the codomain may be the image of more than one element of the domain, and this is the case, for example, with Y1. Y1 is the image of X1, X2, and X3, and that's also acceptable when we write functions. The subset of the codomain that consists of all those elements that are the mappings of elements in the domain is called a range of F, right? Here, this is the kind of a the subset of the codomain that consists of all those elements that are the mapping of the elements in the domain is called the range of F. When we look at here, what is the range of F? There is a difference between this, because I know that sometimes we mix what is the difference between codomain and the range. What is the range of this function, F function here?
Isn't it the same with codomain?
No. Codomain is more general. Y1.
Y1.
Y1, yes, this Y2, Y3, Y4, they are not assigned. They are not mapped from X to Y, okay, somehow. So the range here is Y1, but the codomain consists of, if I write it here, let me write it in this way. Codomain consists of these elements, which are called Y1, Y2, Y3, Y4, but the range only is the one where the elements of X, they have the elements in the domain, they have images. Okay, so you see this difference. Codomain is much more general. Sometimes range and the codomain, they just are the same thing, depending on the situation. So this is one of the things which we pay attention. Şimdi baktığınız zaman bazen herkes kendisine göre bir yerden başlayıp bir takım iddialarda bulunuyor ama şimdi bu ders çerçevesinde bu şekilde düşüneceğiz. Sometimes because people, depending on their purpose, they become even more ingenious, or how to tell, they become rougher. So here the range is sometimes written in this way. Whenever domain comes, okay, what is the domain of function? If there is a function f of x and g of x within the context of this course, like if you see, this means that we are looking at the domain of f. Sometimes you see simply d, but this is what I did here. So the function is defined in this way. Now there are some other things, one-to-one and injective, and this is in Turkish birebir, and onto surjective. So one-to-one is injective, onto is surjective, and invertible birebir ve örten. You can find the inverse or tersine bulabildiğiniz fonksiyonlar. Okay, we would look at these things. A function is one-to-one or injective if distinct elements in the domain have distinct images. So here, if any x, the f of x is equal to f of x prime, it only implies in the case of one-to-one functions, it means that x is equal to x prime. There is no other way. So here, this is again here, x1, x2, x3. And then here, let's take some values, y1, y2, y3, and y3. Okay, and let's take something, y4. What does it tell us? This says that every element of the domain must be assigned into a different element in set y, which is the codomain, like here. Is this a one-to-one function?
No.
I know.
Yes, I guess.
It is a one-to-one function, right? But it is not, it's an injective function, but it is not surjective. You will see it now. So this is a one-to-one because each distinct element of x has a distinct element assigned in set y, right? Burada Y4 açıkta kaldı ama bu bizim tanımımızı etkilemiyor. Ona dikkat edin. Now a function is onto or surjective if each element of the codomain is the image of an element in the domain. Okay, so here it says that it is onto or surjective. Let us draw some others. Here there's x1, x2, x3, and then here I have, let's say y1, y2. Okay, and let me make the assignment. Is this onto or surjective?
Yes.
This is, biz buna ne diyoruz Türkçe?
Örten.
Örten diyoruz değil mi? Yani ne oluyor aslında? Y kümesini, yani codomain olan kümenin hiçbir elemanı açıkta kalmıyor. X'ten bir karşılığı var onun. Peki bu birebir mi? One to one mı?
Hayır, birebir değil hocam.
Birebir değil. Okay, so you have to be careful about it. Onto, örten demek. Diğeri de birebir demek. Birebir burada karşılığı anlamına gelmiyor. X'teki her bir eleman için Y'de bir eleman, yani Y'nin bütün elemanlarıyla X'in elemanları eşleşecek anlamına gelmiyor. Ama şu anlama geliyor. X'teki her eleman için Y'de değişik bir eleman var. Yani X'teki her bir değişik eleman için burada X1, X2, X3 değişik elemanlar. Her biri için Y'de değişik başka bir eleman var. Yani buradan kalkıp işte bir tanesini X3'ü bir de Y1'e gönderirsem olmaz. O zaman ne olmuyor? Injective olmuyor. Burada böyle yazalım. Injective olmuyor. Bir şeyler dondu. Right. Benim ekranımda bir donma oldu ve yazamıyorum. İnşallah böyle devam etmez. Okay, let me talk a little bit about it, and I will try to solve this problem with you. So here we have these onto surjective, one-to-one injective. You can keep these things in your mind, and then we have functions which would. Hayır, ne oldu buna böyle de yazmış? There happened some problem which I have to solve. Haydi. Just give me a minute. I have to. I think you see in the screen. We were going to functions because I planned everything according to the fact that I am writing here. There happened something. I just save this. I will again reopen the document and see whether I have this problem again. Şimdi şöyle bir şey yapacağım. Yazamıyorum çünkü bayağı bir yazmam gereken şey var. Bilgisayarımı açıp kapatacağım. Orada kaybolacağım ama geri geleceğim.